learners, hope you are keeping well. Today we're going to discuss something that you have recommended and I haven't done on any of my shows, is the drainage basins in South Africa. Okay, the drainage basins in South Africa. So the emphasis on drainage basins. Now let's get going. This is the content. You know, you would have your CAPS exam guideline, which shows you these. I'm not going to go through all, otherwise you lose up a lot of your airtime or data. All right, so I'm just going to highlight the main things because the rest of it will be done in the presentation. And I must acknowledge that lots of this content I've used when I did presentations for mindset. So we're going to look at the concepts associated with the drainage basin, the types of rivers, the underlying rock structure, and the drainage patterns. We're going to look at drainage density, stream order, and discharge of a river. All right, so let's get going. Now, what we need to look at here when we look at the concepts itself is not to study them just separately, because they are linked, you understand, to one basin. You have to see the relationship and you see the linkage so you can differentiate and you can understand the concepts better. Okay, so let's get started. I'm going to start in a point where I think will be beneficial for you. So I want to start off with the concept watershed. All right. And let's look at what does it mean. It's a high-lying area separating two river systems. So we have two different river systems. Like, let's just take the example of the Tugela River, and we take the example of the Vaal River. Okay? Now, the Tugela River is on one side of the Drakensberg mountain range, and the Vaal River is on the other side. And the Drakensberg mountain range is a high-lying area that separates two completely different river systems. Okay, so that is your watershed. Then we'll come to what is your river system. Okay, maybe I should highlight. Can you see this high-lying area here? All right, it's mountainous, and then this whole river system in between. Okay, it's separated from the other areas down here. So what is a river system? It's all rivers or stream channels in a drainage basin. So all these channels that are found in the drainage basin is a river system. Okay? So it leads on to what is a river system, or drainage basin rather, sorry. A drainage basin is an area drained by a river and its tributaries. Can you see this area here? All right. Okay, it's found within that watershed, and there's the rivers here draining the water. It flows on the surface and it gets into this river. Okay, so the river is actually draining this whole area down here. All right. Now, can you see the linkage? Okay, now for the area to receive moisture, there has to be some rainfall, and it's a specific area where this rainfall will occur, and that is your catchment area. So around this watershed, can you see it, which is your drainage basin, rain will occur, and this area, okay, will capture the water. So catchment area is the area over which rain falls, and the rainwater is captured by the drainage basin. Can you see the drainage basin here? Can you see it? Captures that water. Okay. Now, other concepts that you would look at: a tributary, which is a smaller river that joins the larger river. So can you see here? We have one here. That is your tributary joining in. We have one here. There's your tributary joining in here, all right, into the main river. Can you see it? That is your tributary. Now I want to look at the word confluence. Is a place where two rivers or more join. So can you see the river joining here? Can you see it? The tributary is joining to the main river. It's a confluence. This is also a confluence, all right, where two streams are joining. Okay, that's a confluence. Then an interfluve is a high-lying area separating two streams, okay, of the same river system. Now you may get a bit confused between what is a watershed and what is an interfluve. Now watershed, we said clearly, there's two complete river systems, Vaal River and the Tugela River. Now, when we look at an interfluve, it's found in the same river system. Where these two, can you see these two rivers here that are joining to form the confluence? There has to be some high-lying area separating those two rivers in the same river system. That is your interfluve. Okay? Now it's all on one picture. Then we have the surface runoff, or sometimes it's called runoff. Okay, not even surface, runoff. And this is when water flows on the surface. Okay, it flows on the surface. All right? And then you've got the groundwater. This is the water that is found underground. Can you see it seep through the ground? It's now found underground. Okay? And obviously, you know that the starting point of a river is the source. It's found in the high-lying area where the river begins. Example, at the watershed. Okay? And the river mouth is where the river ends. Example, at the sea. So can you see, learners, how important it is to link all the concepts? Very, very important to link the concepts so you see the relationship. And that is your concepts that you will deal with based with the drainage basin. All right. We look here also. It shows you a little diagram of how the drainage basin works. Okay. You get precipitation occurring, and some gets, there's it coming down here, and some gets intercepted by the trees. Okay. Then you start getting surface storage where you get infiltration. All right. And as it infiltrates, you will get the soil moisture that will be found now. It's found in the soil. Your percolation will occur. All right. Then you have groundwater where it will flow. Can you see? Into the ground because it's going into the surface. Sometimes there's storage. All right. You will get groundwater flow. Okay. That will flow right through the ground. You'll get through flow where it flows between the rock structures, etc. Okay. You will get surface runoff over land. It's surface going on. All right. Of course, that would be your river channel in where the river is flowing down here. Can you see that's your river channel? Obviously, you're going to get evaporation, all right? When the sun is shining there and heating up and taking it away, all right? You're going to get transpiration from the trees. It's flowing upwards, all right? And there's another important concept here, the water table, all right? That's the upper level of the amount of water found in the ground, okay? And you, of course, when you say saturated rock, where it has infiltrated rock, it has mixed, it has percolated the rock, you understand, rock can become saturated, like an aquifer, etc. Okay, so can you see just a little simple diagram, which you've done over the years, when you've done parts of it in the water cycle, etc. This is processes that happen in a river or drainage basin. Right. Now, the next thing, types of rivers. All right. Types of rivers. Now, you've learned in the past, type of river. Perennial river flows throughout the year. Periodic river, you understand, flows during the rainy season. It's important to know why this happens. Okay, why you are experiencing these different rivers or seeing these rivers occurring. Okay, now we have to link it to the water table. Now let's look at, first of all, then obviously, if you want to know what is these rivers and how they work with the water table, it's obvious that we have to look at the definition of the water table. So let's get going. And we look at the water table here is the upper level of the underground saturated rock, the upper levels where the water has reached. You understand? Obviously, it's going to be lower during the drier seasons, higher during the wet seasons. Okay? So we have to differentiate this. It does vary over the times of drought, etc., but we're looking at it generally. So let's make sense of it then. We have the wet season water table, which contains water during the rainy season. So in the rainy season, the water table is high up. All right. But when it stops or there's limited rainfall, the water table is going to drop. Okay. So it's only during the rainy season. Then we have the dry season water table. This table contains water throughout the year. Okay, throughout the year we have water down here. Okay, so we know wet season only during the rainy season, dry season water throughout the year. So let's now look at this. Let's look at this permanent river. A permanent river flows throughout the year. Right, you know that. But you need to ask yourself, why does it flow throughout the year? Now let's look at it. Where does it cut? It cuts the wet season water table, yes. Okay, so it'll have water during the rainy season. But it also cuts the dry season water table. And what is the dry season water table? It contains water throughout the year. And because the dry season water table contains water throughout the year, this river will flow throughout the year. Can you see now? We need to ask the question, why does it flow throughout the year? Very, very important, learners. Then we come across the periodic river, all right? Okay. Now this flows during the rainy season. Let's look at why does it flow during the rainy season. We see which water table does it cut. It cuts the wet season water table, which has water during the rainy season. Does it cut the dry season water table? No. Can you see the gap here? So therefore, it will receive water during the rainy season. All right. Now the episodic river, it flows only after heavy rainfall, flooding is occurring, etc. And this river flows during that time. And we want to know why it only flows after heavy rainfall. Can you see here? It cuts no water table. So there has to be heavy rainfall. You understand? Not all rainfall gets infiltrated. There's like flooding and this river starts to flow. So can you see the relationship between the water table, the types of rivers and the water table? That's how you learn your work in geography. Because you just know the definition of a water table, of a type of river, you get 1 mark. Applying it makes more sense. Then there is the exotic river. You understand? This actually starts out in a humid area. All right. Can you see it here? Like the Orange River flows through the Free State, which receives rainfall. You understand? And then flows into a dry region. So there's enough water here that allows this river to flow through a dry region, like the Namib Desert, etc. Okay, the Orange River will still flow through there. Okay, that is why it's considered exotic. It doesn't make sense, learners, to have this river flowing through a dry area. Where is the water coming from? But it's coming from the other regions. That's why it's considered an exotic due to its existence in an otherwise arid region. It's exotic, something from somewhere else that's coming through. All right. Now that source of water allows the river to flow through drier areas throughout the year. It's actually a permanent river. Okay. Man can manipulate it and have problems. Like we talk about, I know it's South Africa, like we talk about the Nile River. The Nile River is an exotic river. It flows from wetter regions through dry regions, through Egypt, etc. You understand? So therefore, it's an exotic river, a permanent river. All right. Let's go to drainage patterns. All right. Now we have various drainage patterns, and we have to look at underlying rock structure. We're going to start off looking at and I skipped my slide, I apologize for that, the dendritic pattern. If you look at this, it resembles branches of a tree. Can you see it here? It's like branches of a tree. Okay, that's one of the characteristics of it. And one other thing that we can use to identify, it joins at acute angles. Can you see here? The acute angles. If you look down here, it joins in here. That actually tells you about your river flow too. When it joins like this, it means it's flowing from northeast to southwest. It's flowing in a southwesterly direction. So those are your two things, characteristics. All right, it's quite spread out quite evenly. So the underlying rock structure here is rocks with uniform resistance. Remember, there's a different type things here. We can say sedimentary rocks. That's not the underlying rock structure. That's type of rock. Okay, uniform resistance is the underlying rock structure. Then we get one known as the rectangular pattern. Okay, here it's important to note the main river joins at 90-degree angles. The main river has 90-degree angles rather. Can you see the main river? There's 90-degree. Main river, 90-degree. Main river, 90-degree. But that's the main characteristic. You may find the tributaries also have 90-degree angles, but the main river has the 90-degree angles. All right? For the tributaries and the main river, why does it have 90-degree angles? All right? The underlying rock structure is jointed igneous rocks. So if I put jointed igneous rocks like that, okay, and like that, and if the river has to flow, it will flow at 90-degree angles between the joints. So it's important to know the underlying rock structure. Then we get your trellis pattern. Here the main streams are parallel. Okay. Now, you can get situations where you get one stream. All right? Then you notice that the tributaries join at right angles. Now, can you see this river here? It's one stream and the tributaries join at right angles. So in many cases when you get tested in assessments, etc., you may just see one stream. It does not have 90-degree bends like the rectangular. Can you see it? There it is flowing and the tributaries are joining at right angles, which makes it a trellis pattern. All right, the underlying rock structure is folded rocks or rocks with alternate hard and soft layers. All right, so if you look at folded rocks like that, obviously your river will flow, and your river will flow between the valleys or in the valleys between the folds. Okay, you'll have a parallel structure. Plus, because of these steep slopes, the river will flow down straight to the main river. And the straight flow creates those right angles. Remember, something is steeper, it comes down at right angles. Okay? So it comes down the slope, joins at right angles. Then we have the parallel pattern. A pattern of rivers caused by steep slopes. Example, your ridges, etc. It's caused by steep slopes with some relief, obviously. And because of the steep slopes, the streams are swift and straight. You understand? The steep slopes make it flow straight. All right, with very few tributaries, because it's flowing straight. You understand, through the steep areas, and they all flow in the same direction. Can you see it here? The steep slopes make it flow straight, and they're all flowing in the same direction. Can you see it? That is your parallel drainage pattern. And lastly, we have deranged. Okay, it consists of small streams with no specific pattern. Can you see? There's no real pattern here. It's going through in different ways, etc. And they are considered in flat areas that maybe experience glaciation. So the glaciers move, etc. You understand? They melt, and then of course you got this deranged pattern. Okay? Now, the other two patterns I have to show you on a different sort of system, okay, or different diagram rather, not system. Okay, first we have the radial pattern, the radial drainage pattern. Now this pattern, it radiates outwards. Can you see it? Going outwards, like the spokes of a wheel, obviously, from a high central area. Can you see? This is a high area. All right. Okay. And it flows outwards. An example, you can get domal features. All right. Can you see this is a domal feature? And when rain falls here, it flows outward. All right. Example also from a volcanic cone. When it rains, it'll flow outwards. So it's like a centrifugal pattern. You know, you've done in science also. Centrifugal force, when things are forced or move outwards. Okay, so it's got a centrifugal pattern, and that's the characteristic of a radial drainage pattern. It's got a centrifugal movement. It moves outwards. Okay. Then we got a centripetal pattern. It also does have a bit of the radial pattern, but we're following our CAPS guideline, which says radial and centripetal. All right. So you know centrifugal is outwards. Obviously, centripetal will be inwards. Is when rivers discharge their waters from all directions. Can you see it? From all directions into a lake or depression or craters. So it's moving inward. Can you see it here? It's moving inward. You can see even when the tributaries are joining, the acute angle points inwards into this basin sort of feature. All right, that flows inwards. That's your centripetal pattern or drainage pattern. Okay, so you got your drainage patterns. Some examples. Can you see this river flowing straight, right? And the tributaries are joining at right angles. Obviously, trellis pattern. There's a domal shape here, and the rivers are flowing away from it. Radial pattern. Can you see here the branches of a tree and the acute angles? Dendritic pattern. Remember, learners, you will have to identify patterns. It can come out in map work, or you can get a little map in the theory, but you must be able to identify them. It's not just learning out stuff. It's the visual that you must see down here. Okay. Then drainage density. All right. What is drainage density? It's a total length of streams per unit area. So how many streams found in a specific area? All right. Now, very easy, we can look at it here. All these block sizes are the same. If you look them all around, they are the same. But the lengths of streams, if you add the total length of all these streams, is far less than this area. This area has more streams. And you see that. This area has more. If you add up the total, all the lengths of the streams here, you'll find the total length will be greater, and obviously very great down here. Okay, a description. Okay, so that tells you the drainage density is lower here. Can you see lesser streams? There's less streams per unit area. Okay, here it gets more. So it's medium drainage density. Yeah, it gets a lot of streams. So it's a high density and a very high density. Now, in this case, we can ask you to compare which one is higher, which one has a lower density in terms of drainage density. Now, the next thing we would look at is factors that would affect that drainage density. And why would they affect the drainage density? So, obviously, if there's precipitation, all right, more precipitation, higher drainage density. If there's more water that flows over the area, it'll cut more river channels in the area, isn't it? It'll cut more river channels. So therefore, the density will be higher. Soil moisture. If there's more soil moisture, remember, if the soil becomes saturated, can the soil absorb more water? No. So what will happen to the rest of the water? It will flow on the surface and cut more channels. I'm just putting it in brief here. Of course, you have to explain it in more detail if these things come out. Vegetation, all right? If there's more vegetation, lower drainage density. You need to ask yourself, why? Because if there's more vegetation, it will slow down the flow of water, and water slows down, it will allow for more infiltration, less water on the surface, less channels cut. Okay, so that's how you have to learn it. You make sense. Can you see now we are relating the word infiltration when we did drainage basins in the first part of this presentation to this? You have to explain it. Why does it happen? Slope gradient, steeper gradient, higher density. Why? Because if the gradient is steeper, the water has more energy, it flows faster, it will cut more channels. Learners, I'm just giving you this because this is generally found in most information, but you need to ask yourself the why factor. All right, greater porosity, you know what's porosity? The pores in the soil that allow water to flow through. You understand? So the greater the porosity, the lower the density. Because now if more water is soaking through pores between the soil particles, etc., there'll be less water on the surface, therefore the density, less water to cut channels, lower density. Permeability is how much water can soak into the rock. And obviously if more water soaks into the rock, less water on the surface, lower drainage density because less channels are cut. So greater permeability, lower drainage density. Can you see how we have to answer these things? Okay. If I look at these two, all right, I would say, look here, where's the density higher? The number of streams here, the number of streams here. Therefore, if you look at the same area, all right, same area, but this one has, if you add up the length of all these stream channels, you'll find it'll be more because there are more streams. So therefore the density is higher here compared to where here the density is lower. Remember, the area must be the same. That's how you can do the comparison. Here the areas are the same. Okay. Stream order sounds very difficult. Eh? I just put this diagram. I said I'll explain to you. And it's simple. All right. So we look at this. This is one stream. Am I right? And if it's one single stream, it's stream order 1. If you look at this, this is one stream also. Stream order 1. When the two join, it becomes stream order 2. All right. Now look at here. We've got 1, 1, which makes 2. And when 2 stream order 2s join, we have stream order 3. Okay, there's 1, 1, 2, 1, 1, 2. And when they join, it becomes 3. All right? And when 2 3s join, it becomes 4. All right? Doesn't matter about this other river. That's only stream order 1. For it to form any stream order, you understand? Like if you look at this river, it's joining in here. It still remains stream order 3 because it's not another stream order 3. It's a stream order 1. And for it to become 4, there must be 2 stream order 3s joining. Now you can get tested in theory. You can get tested in map work. All right? They can make you work out things, and you have to look at how many streams are connecting in order to determine the stream order. Then we have discharge of the river, and we have discharge in 2 ways: laminar flow and turbulent flow. All right, now if we look here, this is laminar. It's very smooth, eh? All right, smooth flow. This is turbulent. You can see it's moving around, and it's moving around. It's still getting into a direction. It's moving in that direction, but it's turbulent. Now let's look at the both. Laminar flow is a smooth flow. All right. Generally, the level, the riverbed is level or even. There's not much obstructions in this riverbed. It's smooth. So what happens? All right. The river flows smoothly. Sometimes it can be the volume of water. All right. It's quite a lot. So even you don't see the obstructions here. So higher up, it is smooth, but generally it's an uneven riverbed. Turbulent flow, even riverbed. Turbulent flow, on the other hand, is rough flow. You can see it, which is generally caused by an uneven riverbed. Maybe there's rocks here and there. You understand, and the water is getting in between there, and it's creating this rough flow. I know you've seen this word bubbly flow and foamy flow, but it's a rough flow that will be created in that. All right, learners, that covers your drainage basin. Remember, you must use the past papers and apply it. Use the maps, you understand, and apply all these things. Okay, learners, all the best. Goodbye.